Okay, good morning, everyone. I'm Serena Albertario, and I'm going to start the second webinar of AutoTwin, organized by AutoTwin project and by Syxis. I'm going to share my screen, and then I will ask to each single speaker of today to share his screen when it will be their turn, let's say. Okay, so hope can you see my screen? Okay, so this is the second webinar inside organized by AutoTwin project, having as a main topic the digital solution to support the circular economy. So we are going to see how new strategies and methodologies have been used inside each project, and we are going to compare them. The idea is to start from the real world challenges in order to achieve a scalable solution. As you all know, in the previous session, we knew, let's say, each other a little bit more because we went through description of each project involved in this cluster activity. Per each project, we went through their main objective and the common aspects. Now, today, we would like to deep analyze how the potential for real market is applicated inside each project. So, for this reason, we decided today to, let's say, meet the use cases of each project. I would like only to remember you before starting that this is the second webinar inside a series of three. The third one and the last one will be on the 11th of September at 11 a.m. set, where in this final webinar, we will try to sum up the lesson learned. So the methodologies, the barriers, the social impact, and what could come next. So these are the projects that I would like to thank because they give us their availability to join this cluster activity, and the projects are for sure AutoTwin. Then we have DaCapo, DiCiM and RESTORE. So today we will go through each specific project, looking to the specific use case, trying to understand how they are involved inside the whole project. So what we are going to see, the presentation of each use case, then each specific market opportunities, the possible application of the solution developed inside each project per each use case, and at the end, the challenges and the difficulties found per each project. In general, I would like to make a little bit sum up about who we are. So we are, I'm from Syxis. Syxis is a European Innovation Hub that connects SME, organization, research center. So the main goal of Syxis is to help companies involved in funded research by supporting them with the method, operation, technologies to develop. And the main area in which we are having more experience are the circular economy, the networking, and the digitalization. We are part of AutoTwin, both as technical developers of some components that you will find developed for each specific use case, but also we are in AutoTwin with the role of involving the project in clustering activities like the one we are doing today, and also in AI for manufacturing community. Okay, so the order that we would like to follow today, due to some also problems of times, let's say, related to some partner, is to start with DiCiM, then to go to DaCapo, RESTORE, and at the end, AutoTwin. So, hoping that this order could be fine for everyone, I would start from DiCiM. Then I would like to remember you that there is the possibility for sure to intervene during a specific description of the use case from a project, or if you prefer, you can use the question and answer section that you find inside our call. Okay, so I'm going to interrupt my sharing of the screen and starting with the DiCiM, I would like to give the stage to Michael Kral. Or I don't know if no, Gyorgy.
No, I will not be presenting. Gyorgy will be presenting.
Okay, no problem for us for sure. So thanks for being here, Gyorgy, to represent DiCiM. So I'm going to give the stage to you. And once again, I remember that we have the question and answer section in which you can write down your thoughts or any kind of question. Thanks for the attention. I'm going to give the stage to Gyorgy. Thanks.
All right. Thank you, Serena. Good morning and welcome, everyone. So my name is Szemeredi from Lexmark. Feel free to call me George. I have an impossible Hungarian name, so probably George will be easier.
Sorry, I read Gyorgy. I said Gyorgy.
No, that's perfect.
George. Okay.
I mean, I like Gyorgy as well, so I'm absolutely fine with that, Sarah. Yes. Don't worry about that.
Thanks.
Okay, great. So please confirm if you see my screen.
Yes, we see.
Okay, great. So again, good morning, everyone. I hope everyone is having a great day. So since I thought that we're going to be the last presenters, I didn't really prepare my slides, but I just in time. So this is the first slide I like to show you about our short presentation. If I'm not mistaken, we have 15 minutes for this short presentation. So that's why we like to be mindful on time. So the title of the presentation is Advancing the Circular Economy Through AI-Driven Digital Innovation. And our use case is a printer use case. So we're talking about the printers today. And there will be two presenters. So we discussed with the Ljubljana University that I'll be the first one introducing Lexmark. Probably I'm going to talk less about the company itself, and I'm trying to focus on the innovation and the developments we've been working on together with the consortium partners. So in the second half of the presentation, Miha Kodric will present the technology they developed for this solution, what we're going to talk about, and feel free to interrupt me. So if you have any questions, please jump in and ask me to clarify any of the discussion points in the next 15 minutes. All right, so let me go to the agenda that I already explained. So first half is Lexmark, second part will be the university part. We're going to talk about process innovation, and the developer team will talk about the data processing, AI, and ML integration in our reverse logistic processes. All right, so just a few words about the Lexmark innovation. It can be important. So basically, Lexmark has built more than 30-year legacy in sustainability, starting with cartridge collection in 1991 and LECP in 2003. So LECP stands for Lexmark Equipment Collection Program. We have expanded globally with eco-label certifications and circular design principles embedded in our products. Our printers now include significantly more post-consumer recycled PCR plastic, quadrupled since 2010. And our cartridges are primarily comprised of the same materials as the hardware and are designed for zero waste to landfill. And 3 of our global facilities are certified zero waste, and we have reduced total carbon emission by 52% since 2015. Let me go to the next slide. So Lexmark is the only printer OEM participating in these 3 EU-funded research and innovation projects. We play an active role in research, advancing digital product passports and circular economy policy innovation. A Lexmark circular approach is strategically aligned with EU policy, and global sustainability goals like the Circular Economy Action Plan and the CDG 12 and 13. So our improvement and innovation reflects incredible recognition for respected academic and industrial partners. Backed by funded multi-year EU research, our work contributes to measurable progress in circular economy and circular innovations. So regarding the product we selected for the DiCiM project is one of the high-end devices. This device is a MS8 series, and this device includes high-tech technology, meaning that obviously the technology that prints the pages, it's the most important outcome for the users and for the clients, or the output we can call it. However, the technology at Lexmark is not only focusing on the function and the features, which is the main feature of the printer. In our printers, we have integrated health check system, which contains more than 200 sensors in the machine, measuring the working conditions, measuring the components and part conditions throughout their entire lifetime.
Yeah, how do you know?
I can hear someone from the background, so maybe someone has a question. Or maybe not. Okay, no, that's fine. Okay, so let me move on to the next slide. So basically, the main innovation that we've been working on together with the Ljubljana University data engineering and data science team is that today at Lexmark we have a kind of manual circular model, where we need to do so many manual interventions when we're selecting the printers for returns and when we're deciding which printers should come back to Lexmark. So today we have no visibility on the device condition, the health condition. So imagine just one example. For example, in Spain, we have 200 printers, what the client is claiming for return. Then today we cannot say which out of those 200 printers are representing value for Lexmark. So we need to bring the printers back to the warehouse, to the return center, and we start analyzing the printer condition, the components conditions, and after we already shipped the printers from Spain to Kiel to our warehouse, then and in Poland, which is our return center and return and remanufacturing center, that is the moment when we receive already units back. We already generated footprint, which is not really an ideal case. And then afterwards, we select the printers for dismantling, remanufacturing, and recycling or disposal. So if we're scrapping printers, this is something what we could do locally in a country, since Lexmark already paid the product environment fee. And in Spain, we have many solutions to do the local recycling and the local scrapping of the units, what we don't want to use for remanufacturing or any RE strategies. In the future, we plan to have a AI-supported circular model, meaning that we have remote control and remote condition detection on Lexmark printers. So the example that I just raised, 200 printers in Spain can be easily detected out of which 200 printers, which printers we need and which printers represent value for Lexmark. So we can select the printers out of the batch of the claimed units, which printers we believe can do something and what we want to receive back at our warehouse. So basically, we do this pre-selection of the printers and not only deciding about returning the printer back to the warehouse, but with this device detection, remote device detection model, we can already judge if the printers can be repaired in the country on the site of the customer. And if the printer can be repaired there, then it is also another option from the user to go for the repair option. So basically the user will have 3 different scenarios to choose from. One of them is the repair, which is, I think it's one of the best solutions expanding the lifetime of the printer. The second one is the return. So when Lexmark confirms how many printers out of the 200 printers can be returned to Lexmark, then they can decide if they want to send it back to Lexmark. We have a buyback program as well at Lexmark, so we can offer a price to that. There are some printers what we cannot really offer a price, so we can bring it back for free, or the customer can decide about scrapping in shipping the units to the local scrapping location and generating less footprint by shipping the units back from Spain to our return warehouse, which is in Poland. So moving on to the next slides, let me just go real quick. Here we're just listing some of the development outcomes and the gain benefits of this newly designed innovative solution, what we're working on together with the university and with the partners. Not going through the entire slide, but just the last statement that you can read at the bottom. So basically, we designed a system to collect and analyze device data via an open access digital platform using AI to support the after sales, making a smarter decision in repairs, returns, and remanufacturing. And having that mentioned that we're using an integrated system for data transferring and customer claims, this is the integrated communication system platform, which is called OEDP, developed by Significant. So this is the web platform where we communicate with the clients, and we can communicate with the university, and Lexmark data engineers can also communicate with data science team members on the university side. And basically, this is the last slide I was going to show you today. And from this point, I'd like to pass the word to Miha Kodric to continue with the Ljubljana University developments from the university side.
Yes, hello also from my side. Can you hear me?
Yes, we can hear you.
Yeah. Okay. Great. So hi, my name is Miha Kodric. I came from University of Ljubljana, and we are part of the DiCiM project, which contributes to the project as technology provider. So also for Lexmark and also for Gorenje company. We belong to Faculty of Mechanical Engineering, and we are part of the laboratory called LADISC. So we are primarily working in the dynamics of machines and the structures. So we've been traditionally focused on the classical mechanics like Newton and Lagrange and Fourier, but in the past decade we have expanded our focus also into artificial intelligence, combining it with our mechanical expertise. This shift has allowed us to address new challenges such as sustainable packaging, predictive maintenance, and decision support for the end-of-life process. And this transition, you can clearly see here on our timeline. Here is highlighted just a few European projects focused on circular economy and structural durability. And on the next slide, on the next slide here we can see what were our tasks at the scope of the DiCiM project. So our task is to support Lexmark in optimizing their return, repair, recycling workflows. The core idea is to estimate the condition of a printer and recommend the most suitable next step for the remanufacturing process. This evaluation is data-driven, so it's based on sensor collected data during the printer's life cycle, like previously Gyorgy mentioned. So fortunately, the Lexmark already collect the operational data in a highly structured format, so we could use them quite easily. Although we faced some issues with the missing data, and nevertheless, we could successfully develop an anomaly detection system that can identify the unusual behavior of key components, which often indicates wear or a failure, and help us to estimate the printer's overall condition. And maybe on the next slide, here we can see how we developed our system. So developing was quite challenging due to complexity of our printers. Each printer includes numbers of independent components, and they're all influenced by different settings. So we can set a different printing speed, different duplex mode, a paper tray selection, and all that. So these parameters directly affect the motor speed, the motor loads, heating times, peaking times, everything. So these parameters can also be influenced by the component wear. So both contribute to the measured values. So understanding which variations on the monitored values are due to the settings and which are due to some degradation. This was the key question in the scope of this project. So we analyzed more than 700 gigabytes of data, and for more than 12,000 printers. So this large data set allows us to train and validate the reliable models. And on the next slide, here we can see how we handle this complexity of this huge amount of data. So we took a two-phase approach. First was the training phase approach, where we used the data from the first 500 printed pages for each printer, where the wear was minimal, and this data was used to train the machine learning model to predict the expected parameters based on the printer settings. So this was early stage of a printer lifetime where everything should be normal or nearly close to the perfect condition. And on a second stage, second phase, we call that detection phase. We then analyzed the last 1,000 of printed pages, comparing to the actual values, those actual values to the predicted values. So for each setting, we predicted the expected parameter values and compared them to the actual measurements. If the deviations were beyond a predefined threshold, we flagged this as a potential issue, as potential anomaly. So this approach allows us to detect signs of wear or malfunction on a component level, and also for the whole printer. And on the next slide, here we can see what was our outcome. So to make this system practical and easy to use, we developed a 5-level grading system that combines those deviations and also total page number count and also error frequency. All these parameters are combined into one final grade of the machine and also for specific component. We also built an interactive 3D visualization tool that shows us the health status of each component, trends over time, and recommended next step. So either recycle, take back, or buy back with a price offer if that is an option. We also created an API for integration with external platforms, such as in our case, OIDP, which was developed by Significant. So by accurately assessing the printer and components health, Lexmark can reduce the returns of heavily worn devices, like Gyorgy said before, and extends the product's lifespan, so directly supporting the EU goals for sustainable product life cycles. And that's all from my side. Thank you.
Thank you very much. You've been in your time. Thanks also for this. Very interesting, and I already see some similarity with the AutoTwin project in which we are, for example. I don't know if there are any kind of questions from the other participants. Otherwise, we could go to the second case, that is the DaCapo project. For DaCapo, if I'm not wrong, today we are going to have Rula and Johan.
No, Johan.
Johan,
Yes,
okay.
I don't know if you would like to say something as a start. Otherwise, I will go ahead.
From my side, you can start. Yes.
Okay, it's my first time in this forum, so hello everyone. My name is Johan Vallhagen. I work at DiCiM Aerospace in Sweden. I'm in a position in a team working with collaborative R&D research and development, but I had my background in our global technology organization, so I was part of the initial work of the DaCapo project as at least. I'm following some of it still and supporting a bit. Let me see. So yeah, some formal information about our DaCapo as a reference. I will not go through that now. GKN then, we're an aerospace company, and we have 3 different business areas or domains, we can call it, in the civil airframe business, the defense airframe business, and then the engine part where I belong, or the headquarters in Sweden. And we have a position in the market where we call ourselves a tier 1 supplier. So the big part of our business today is to design and manufacture various components for turbofan engines, so jet engines. And we have a quite strong position around some components then from the mid to large size engines. Today I will talk a lot about what in our business is called MRO, maintenance, repair, and overhaul. Nowadays it's becoming very popular to talk about remanufacturing, and I would say that MRO translates just about to identical to remanufacturing in my world, at least then. I had to show this from our standard corporate presentation, but I would say we have a relatively clear and ambitious approach to sustainability. To the right side there you can see some milestones, and I think maybe we were not the first, but I would say we were among the first in the aerospace business at least to commit to the science-based targets. So we are now in the phase of doing those kind of assessments and understanding where do we need to be then over time to actually fulfill that. As I work with technology, R&D, we have a lot of focus on that as well, both of course for the original manufacturing of parts and in particular also how we contribute to the design of future aircraft and future propulsion systems. But also in our operations then to reduce whenever possible among the scope 1 and scope 2 emissions and sustainability impacts. Motives then for having this kind of focus on the aftermarket business and the circular manufacturing is explained here. To the right side there you can see some diagrams, and whether you like it or not, this is the forecast for the aviation business, explained in the number of aircraft, which is the forecast for the next 25 years. It will maybe not grow that much in Europe, but definitely in some other large regions of the world. So there is a substantial amount of new aircrafts and new engines that need to be produced over the next 20-30 years to meet these expectations then. At the same time, what we call the MRO business then, maybe not many people knew that, but it's actually bigger today than the original manufacturing business of aircrafts and engines. And it will grow even more than over this next 25-30 years. And there's a reason for it, of course, when there's more aircrafts flying, but there's also the limited capacity of the industrial systems of today, so there won't be capacity available probably enough to do it, and instead you need to repair parts to keep the current and future aircrafts flying. And of course there's a lot of incentives now also from sustainability perspective, reducing the amount of material you need to put into this industrial system, but also related to resilience. So some of the specific challenges here then, we need to see larger or higher volumes. The next generation of engines will have higher requirements. Industrial system capacity, as I talked about it, and sustainability and resilience, there are ambitious goals we need to achieve there. And the means to get to it is a higher level of automation, so in all steps of the process from performing this kind of maintenance, repair, and overhaul. The quality, both from the future engines requirements, but also we see a potential to maintain to a higher level or repair to a higher level of quality, which also will have an impact on the performance and fuel consumption of the fleet flying at the moment and over its lifetime. Cost competition is there, of course, in different ways, and there's a big need of new technologies because what we see ahead of us in about 3, 4, 5 years, those parts cannot be repaired with today's method. So there need to be innovation and solutions available and to actually accomplish what the plans are or what ambitions are. So for the DaCapo project, and the title here, extending the sustainability and repairability. Of course, we do a lot of work to try to first reduce the need of it at all, or the need of material or different consumables and energy, and then to do it as efficient as possible, what is required to do then. Our use case in the DaCapo project is illustrated like this. The DaCapo have a life cycle perspective stretching from how you do initial engineering or engineering to support over its lifetime, how you manufacture or how do you actually, in our case, then perform the repairs. It connects also then to the use phase. How can you assess, or in which way do you need to assess the parts to predict and make judgment about the need for repairs and spare parts. And then we have additional tools in the scope to support. One of the things is digital product passport that we see will come sooner or later also to our business, and it could provide a lot of relevant information on the aftermarket to plan and make better data-based solutions to perform the repairs. Data management solutions or interoperability solutions with digital thread is extremely relevant and important to accomplish what I will show soon, and also that we can make the right kind of assessments of the life cycle impact or the life cycle assessment of what we're doing. To the right side there, you see some numbers. I would say on the top there, this is very from a holistic perspective, that if we can repair parts, we typically save at least 80 to 90% of the material or resources required to produce new parts or spare parts, then even up to 90% in many cases, because there are small features being worn and the sensitivity or fatigue life of these components are critical. So if you can have advanced solutions to actually manage that, there's a lot of improvements to make them. But also looking at the conventional methods used today, we now look more and more into using different type of additive manufacturing, and also we can see the potential of going more and more into that, because there are actually big steps to make if you can implement that. Maybe not that big on the holistic level, but of course still continue to make improvements to take us to the net zero vision or similar type of goals then. Yeah, the theme for the presentation was around digital twins. So this typical illustration or definition of a digital twin, that you can actually study the physical object. You have a model that represents it, and in the ideal case you can also control what happens in the physical world. And also you need a good visualization, and yeah, the overall purpose is to make better decisions. So how you can empower the people using it is quite important also then with the decision support aspects. This is, let's say, I'm showing now more the core business or the core development from the GKN side in this project. There are some additional things I can mention as well in a few moments. But here you see then different perspectives on what we do. One is the product. I mentioned in the beginning that if we can assess the condition of the product, which we can, or we are continuously developing our skills to do it, and also then on break it down to a component level. We believe that this can help us then to set targets for the quality of the repair that possibly can then be executed. We're not there yet, I would say, but that's part of the scope or part of the vision to do it. And if you can make some such predictions, you also want to have specific requirements on how the process to repair then should be performed. Either it's the machining part or polishing, or where you add material to the parts. So there you also need a good opportunity to virtually design or predict or do the process planning. Ideally then on a part-to-part basis, so it has to be quick and very efficient, because otherwise it will cost far too much. And the process is one view or one perspective of it, but looking then if you want to understand what's the total impact on sustainability, you need to study the repair system as such, and then understand what are the different types of energy and consumables required to do it, so you can do the complete life cycle analysis of it, and also then make choices of which kind of method you would like to use, yeah, depending on a lot of circumstances and trade-offs needed then. This does not perhaps show the DaCapo solution right now, but something we have in-house at the moment. It will connect to the work we do in DaCapo, but this was the, let's say, best illustration I had now to actually explain our approach to this digital twin concept, and also how we can actually do it today. So the bottom part here is very much related then to the machine system behavior. You can have a good connectivity with low and high frequency data, and this software called Synertrain, which simulate or emulate your components and the control systems of your moving parts of your machine tool. So that gives you a very good opportunity then to assess the behavior of the machine. I will show soon what that can mean to us. And then you also have the process part. On top right side here, you see something called Vericut, which is a software that you can simulate the machine kinematics and some of the dynamic behavior of the material removal, and you can then calculate also energy consumption required and to cut the material. And in addition to that, as I mentioned before, the pure material removal is one thing, but then you have a lot of other support systems on the machine or equipment level, which also then contributes to the overall impact of sustainability. So here's some detailed examples then that you can study with this type of approach. So if you have a trajectory or several trajectories machining a certain geometry, you can then compare, for instance, how you do different machine system settings. In this case, the limit of maximum acceleration set on the feed axes of the machine, and then you can also see what impact does it have on the energy consumption, and then you can, for instance, compare then if you run the machine very quick to complete one operation step, or if you choose to do it with less accelerations, you can have like a 50% longer cycle time, but then you also can reduce the energy consumption with 35%. And if you put that also then in the perspective of what does the total machine system actually consume, so the feed power of the machine component axes is the brown diagram here with all these peaks when it moves, but the biggest contributors are the more static consumption from different pumps and cooling units of the machine. So it's very important then to make the right choice of machine and machine system and how you run it to get a full picture of the consequences of how you choose to do the repairs. This is a slide then to put this in a more holistic context, because that is quite important. It's easy to get buried in details. But what we want to accomplish with the combination of this digital twin approach and some other of the tools done in the DaCapo project, it's intended to be a platform supported then with a digital thread solution to get this integration and interoperability. And on the bottom side there you have the analysis tools that helps you to do it, and a data transferring tool like the digital product passport, for instance. But we also have elements of visualization and decision support, which will be quite important. So when this part comes to our shops, we need to do an inspection and a damage assessment of this. To do it manually, as it's done today, we have very highly skilled and trained operators, but for the future then we see good opportunities to introduce more and more automated visual inspection with AI analysis of the slides. And this is an example of illustration then how you can get that presented to an operator, and also get the support to identify where you have different type of defects. You can also document what you see, so you have a full digital record of it, which also would be a very valuable asset over time. Today still much is done and documented on paper in the aerospace business. And then we have also then connected to how we foresee that we can have alternative repair options. This is something developed by you from Kåre, Raula, which is here then. So combination of the alternative repair methods we can do, how we can assess the damages, and how that also then could relate to the impact of the components quality or the overall performance of an engine. And we can then put that in relation to, okay, if we want to spend more time, resources, material on repairing, we will consume more, but there's a potential other impact on the use phase then. So such trade-offs and help to see and understand what are the better choice to make then is coming out of this decision support. And yeah, then you have the repair execution and delivery, which then is documented through the and supported by the digital tools available to us. So where we are at the moment, we see this as a very potential concept, and we're approaching a proof of concept. This is a research and innovation action, so it looks promising, and some of these things is a bit on the threshold to that we can start implement, at least in our research and technology lab environment, at least. All right, that's what I plan to talk about.
Thanks, Johan, for your speech. I don't know if there are any questions. Otherwise, I would pass the floor to Restore. And for Restore, we should have Diana, and the relator Sayedur.
Oh, probably I don't find Diana in the group in the meeting. Probably.
Are you going to present?
If Diana is not available, then I can present my part. Practically, Diana supposed to present, introduce the Restore project to the participant, and for Restore tools and use case, I supposed to present. But
okay, yes, I don't see Diana in the call.
Okay.
Okay, we can see your screen.
So as if Diana is not available, probably she had a meeting and she told me that she will join at 10:30, but she
okay,
is not.
So would you like maybe to ask to AutoTwin to anticipate, and you are going to be the last one? For us, it's the same. If Nikla is available, I see her in the call. We should make this change as you prefer.
You can change if the next presenter is available.
Okay, Nikla, could you start? Are you available?
Yes, I'm okay. Let me share.
Okay, so we make this change. So now we go through AutoTwin, and then we put Restore at the end. Thanks, Nikla.
Thank you.
I think you are looking the wrong screen now. So
Sì, exactly.
Aspetta un attimo. What about now? Now it's correct.
Perfetto. Thanks.
Okay, so hi everybody, I'm Nikla Frigerio, and I'm here on the behalf of the project coordinator, which is Andrea Matt, not available today. I'm going to give you a bird view of the use case in AutoTwin, which is the project has been presented already in these webinars. So as many other projects here, we are working in a context moving from a linear manufacturing and a linear economy to a circular manufacturing and a circular economy. So we are facing an evolution from the traditional take, make, use, waste model to something that has multiple loops and not linear path anymore. So the main feature identified in AutoTwin of this, let's say, transition towards circular economy are the, let's say, the occurrence of closed loops, the fact that products are present for a long period of time in our economy and our manufacturing, so the longevity of products, a topic of resource efficiency that is even more important in circular than in linear economies, and stochasticity overall for the overall systems. Okay. Now, going into one by one, we mentioned the closed loop. And so materials flows are not linear anymore. We have those non-linear paths. And if we go through the literature on value retention option, we see that there are short loops, such as repair and reusage of materials, medium loops that are consistent with remanufacturing, for example, or with refurbish or repurpose of goods, and very long loop that take into consideration recycle and remine, for example, of materials. So the fact that the part go through those non-linear paths also imply that a product can be in a loop many times. And whenever they pass through the same resources, they may need the very same resource for traceability purposes. And so there is a correlation between product in those loops that we cannot disregard. Another point is related to the longevity. So because products go around and around in a circular manufacturing chain, the traceability of item is even more important than before, and is also difficult to be maintained because the traceability may be lost when we go through a circle to another circular market, for example. And this is because information may also be unreliable. And the severity of those problems, of course, increase while moving from a short loop to a long loop. The third point was related to the resource efficiency. Why that? Because as per linear economies, the resources affect the time spent by material in each part of the value chain. And there is a finite capacity in terms of number and also availability. So those characteristics of resources also impact different behavior of the resources that are dependent each other and that can be stochastic. So modeling circular economies without explicitly representing the resource can be an oversimplification of the problem. And so for this reason, digital twins of circular economy need to have good model for representing the resources, whatever resourcing may mean in the particular use case. And then the last point was related to stochasticity, because of course, there is a stochastic nature of material and processes, and we cannot get rid of stochasticity in total, let's say. Also, the consumption phase of a product is really highly variable. And we have stochasticity in the return time of a product, but also in the quality level of the product that comes back. This can be the state of the object. For example, in the printer that has been presented before, the usage may impact the state of the object of the component when it comes back. And also, we need the cost in order to bring the object back, as we have seen in the Aerospace example, when different, let's say, repair was needed. So the costs are also different. So now going back into AutoTwin, we have 3 use cases that somehow make different example of all those features that I just mentioned. The first one is we call Battery Cloud Platform, is with the company Libation. And this company takes old, let's say, module or cell of battery cell, and they choose whether to refurbish, to repurpose them, or to simply recycle because the state of health is not enough to be actually refurbished. And so they are working on the two loops that are in the middle loops, called refurbish and repurpose, because every time they have a new use cell incoming, they have to choose whether to repurpose in a pack or to substitute in order to bring the pack again to a reasonable condition to be used. Here, the actual state of charge is difficult to be predicted, and the fact that we have a digital twin of the product can be a very important tool in order to make a decision in this particular pilot. And because of the different usage of the rack, we need constantly updated data about how those batteries are used. The second use case of AutoTwin is related to PET recycling, and the company is green. Of course, we are speaking about recycling, so here we are in the longest loop of recycle, where PET and in the specific post-consumer plastic waste and also textiles, so textile which contains PET, are shred. And then they are chemically recycled in order to have a virgin equivalent PET. So the process is very complex here. You have a lot of phases because of the chemical reaction you need to take into consideration. And everything is automated. So you have a very complex situation, but finally, everything is automated and controlled. So the process is complex, but the stochasticity is very small with respect to the process. On the other way around, the quality of incoming feedstock may affect a lot the efficiency of the system. And so having a digital passport of the incoming product can be, for example, a very valuable information to have. The last pilot is related to Chroma company, and they deal with the sterilization process of medical devices within a hospital. So medical devices used into operating theater, they can be used many, many times, but of course, in order to avoid any contamination and risk related to the health of people, they have to be properly cleaned and sterilized. So here we are in a very close loop because product into the system must remain into the system. Everything is traced, and traceability is very important because we are dealing with a hospital here. And of course, the consumption in this case is the usage of the medical devices in the hospital, and the company needs to somehow repair them. So to recycle them in order to, to sterilize them in order to maintain the medical devices at the proper condition to use. Here, the sterilization center and the hospital are very closely connected because the number of medical devices is fixed. So it is either in the in the sterilization center, either in the hospital, causing a strong correlation between the two entities in this value chain. So now, if we want to give, let's say, the map, again, the bird view of our use cases, we can see that over the value retention option, and the return time of each product, so how frequently the product comes back. This is related to the longevity. Chroma is in the short loop, and the product comes back within days or at most weeks. Whether Libatio, we are a little higher, so we are in the middle loop, and product come back in month or even year. And for green, we are in the recycle, so long loop, and product may come back after a very, very long time because of the usage of clothes, because of the usage of plastic. And so, as you can see, AutoTwin with its use cases covers more or less all the challenges that we mentioned before. In terms of complexity, here we have process complexity on the vertical axis, process variability on the horizontal axis, and we can see that green stays in the middle in terms of complexity because we have many process, many steps, but is all automated and well-defined within the domain knowledge. On the other way around, the variability is low because everything is automated, but the key is behind the domain knowledge needed to understand the data. So you may have a lot of sensor, but the problem is to understand what those sensors mean, what each data mean. Libatium is not very complex. So you have those cells, they have been charged and discharged, so the process complexity is low, but you have middle variability because you may charge and discharge very differently. And so despite this, the customization is not very large, but you need to know the battery technology behind, and you need to know a little bit of the usage of the battery. Chroma, instead, is very high process complexity because it's mostly manual, and it's very high process variability because you have a very high range of products, medical devices, and a very wide range of usages according to each surgery type, emergency, and so on. In terms of variability of the material and the material state, chroma is very low. The material is there, is known, every medical device is traced, and it can be inspected very easily with control chart. For Libatium, the variability of material matter is low because they have a known set of chemical inside, but the state of charge and health is very variable. So the difficulty is to understand the state rather than the composition. For green is both. You don't really know what is the exact composition of your feedstock, and you don't really know if there are some contaminant or not. You have nominal information, but it's very hard to be sure about this information. And so what AutoTwin is actually developing is a digital twin of the product for Libatium. So we follow the product and we try to understand information coming from each individual product. Whether for green and for chroma, we are making a digital replica of the system because the interest was more related to understanding the flows and understanding decision related to dispatching rule, forecasting of the behavior of the system rather than the behavior of the product. And again, in terms of what are the digital services, or let's say the external services, the digital system, the digital twins we are developing now to twin, let's say, provide to the use cases, we have three macro type of services: description-based, prediction-based, and prescription-based. The first two relates to diagnosis and monitoring of product and resources. Prediction relates to forecasting some key performance indicator. Prescription means anything used to control the system or to design. So to understand changes to be introduced in the real system. And as you can see with our three use cases, we are touching all the services. And so in AutoTwin project, the consortium has faced challenges different, I would say, but also with a lot of similarity. And this allows us to cover many different, let's say, situations we may have also in other use cases. And with this, I thank you and I close my presentation. If you have any question, I'm very much available to answer.
Thank you very much, Nikla, for this presentation. I don't know if there are any questions. Otherwise, I see that Diana is here. So Diana, please, we could proceed with the last project of today, that is RESTORE.
Yes, so for RESTORE, Sayadur from Technovative Solutions is going to present.
Okay.
Yes.
Okay, because before Sayador was waiting for you, so now you are both here, you can arrange your speak.
Yeah.
Yes. Okay, we can see the screen, but we cannot hear if Sayador is speaking. Okay, now I can hear you.
Sorry, can you hear me now?
Yes, please.
Sorry. My speaker was okay. Thank you. Good morning, everyone. Thank you for joining us today for this webinar on digital solution for the circularity economy. I am Saidur Rahman from Technovative Solution, TVS UK. TVS is involved in many EU-funded projects, and in RESTORE, TVS is developing digital tools, including digital product passport, DPP, life cycle assessment, LCA and cost model, circularity calculator, digital marketplace, and overall the RESTORE platform. I am presenting the RESTORE platform and use cases. We have 4 use cases, and there are 4 use case partners. RESTORE platform is a European initiative that brings together sustainable remanufacturing, digitalization, circularity strategy across several industrial sectors, covering components that cannot be repaired or need excessive heat input or dilution, as well as requiring extensive power post-weld machining or need preheating and post-welding heat treatment, and some cases need to be replaced by more stronger component.
The slides are not moving. Maybe there is a problem. Yeah. Okay. Maybe you can put in presentation mode. Yeah.
Okay, now it works.
Okay. Sorry for the inconvenience. RESTORE stands for Sustainable Remanufacturing Solution with increased automation and recycled content. The project focuses on laser and plasma-based remanufacturing processes and also hybrid process, supported by digital tools that makes the whole process smarter and more sustainable. Our main objectives are therefore increased use of recycled materials, specifically for the wire, and automatic complex remanufacturing task, and create a digital platform that integrates simulation, traceability, and lifecycle sustainability. The platform supports all this through 3 layers: physical layers, physical manufacturing layers, service and automation layers, and the software tool that and collaboration spaces. Let's dive into the platform structure. We have in the bottom, we have physical structure having laser DED or direct energy deposition, plasma transfer arc welding, robotics, hybrid setups, that is LED, LDED, and combination of DED and PTA. These technologies perform the actual remanufacturing and feed data into the RESTORE platform. The next layer is the real-time service layers to process automotive framework, damage characterization. We have to find out the damage, where the damage is there, and generating the CAD file, toolpath generation to translating the design into a robotic instructions. Then we have virtual twins. We will simulate whirlpool behavior using a whirlpool simulator, perform process optimization to tune heat, speed, and feedstock rate, store ideal settings in a recipe book. From all these different variables, we will prepare a rich recipe book from where we can get the available data, and which can be fetched to different DPP and other LCA model, and apply the product optimization for performance and material efficiency. We also support sustainability modeling, including LCA. LCA will use CIMAPO and eco-environment database, circularity calculator to assess recyclability and reuse potential, cost modeling, and decision support system framework to guide eco design. At the top of the collaboration space, we will use a digital product passport framework, a digital marketplace for services and knowledge exchange, business model templates, blockchain and ontology integration for secure, blockchain for secure, and ontology framework for interoperable data sharing. Everything is tied together with a single graphical user interface GUI, and that connects to third-party tools, database, and actors of the value chain. Now, so for this we need to integrate the different tools. Restore is a strong ability to connect external tools via API. So API includes LCA database like CIMA-Pro and EcoInvent, ontology-based data system built with web ontology language, third-party simulation, and ERP platform integration with different tools. This ensures that data flows seamlessly and stakeholders, whether technical or business oriented, and have the information they need to support circularity and traceability. Now we are going to our use case. We have 4 use cases. First one is Railway Excel. In Railway Excel, current measure is like that if machining of maximum 2 millimeter is needed, more than 2 millimeter, we have to replace the component. So there is a huge loss of material. So we want to make a technology so that more than 2 millimeter can be reused by additive manufacturing process. The goal is to repair only the worn areas, and especially the around the transitional ready without affecting the axle's integrity. Next one is our recycle of continuous casting roller. Continuous casting rollers now submerged arc welding is used, currently employed, but it requires huge input power, and there is a possibility of greater dilution, and it is also required extensive post welding machining. So our goal is to use a remanufacture so that the life of the life of the new roller caster will be improved, and with a very low energy and raw material consumption. And we have use case 3 for redesign marine propeller. In marine propeller, there is a several during use of there is a gravitational erosion is very common in, and problem is that during the we have to use a TIG or metal insert inert gas welding, and which required actually preheating and post welding heat treatment. Now we will use additive manufacturing project which will reduce the waste and enhance the hydrodynamics. In automobile component, in the front end of the automobile component, currently there is no possibility of use the component. We have to replace the component with higher strength. So it is completely new approach, and we want to use this as we call it a new innovative approach. So each of the use case applies core restore component differently to providing that circularity data driven remanufacturing in both practice and scalable. To summarize, Restore provides a full stack solution for sustainable remanufacturing. If it automates the complex additive and hybrid remanufacturing process, embeds real-time analytics and simulation, supports circularity through LCA, cost modeling, and digital passport, and enables traceability and collaboration through secure digital infrastructure. We believe RESTORE is a model for how manufacturing can become both smarter and more sustainable, not just in theory, but in real industry practice. So thank you. If there are any questions, I can.
Thank you very much. So this one was our last speech for today. I don't know if do you have any question or answer, or something that you would like to discuss about? Okay, given that we are going to conclude the webinar, I would like to remember you that our final moment for these cluster activities will be on Thursday, 11th of September, at the same time of today, 11 a.m. set. And this will be our final step. So lesson learned about this flow we did through this different project, and how we could improve our approaches and create synergies also among us, given that very often is something requested also by the European Commission. I see an hand up from George. Yes, please.
Yeah, thank you, Serena. Can you hear me?
Yes, we can hear you.
Okay, great. Thank you. So just a very short question for the RESTORE team. During your presentation, you mentioned the LCA solutions you apply. And my short question is if you have LCA modeling for remanufactured products as well.
Actually, we are now in 18 months, and we are now have prepared the LCA model, and we are sharing the model with our partners. And after getting feedback from that, we will use the CIMA Pro to make it actually front end. We will develop a front end, and using CIMA Pro and equipment, we will. Yes, we are going to develop a LCA model for remanufacturing. Yeah. Do you need anything more?
No, thank you. Actually, this is one of the main focus items for Lexmark as well, to start measuring LCA for remanufactured products in the future. We seeking for some solutions. We haven't put a process together, and there is no existing process in place. But this is the next chapter for our LCA development and innovations, to create and publish LCAs for remanufactured products as well in the future. Thank you very much for your answer.
Okay, so if there are no more other questions, I would like to thank all our speakers of today, and also the people that joined this webinar. So we will keep in touch some weeks before organizing the final one, and thanks again. Have a nice day.
Okay, thanks.
Thank you, everybody.
Goodbye.
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 Thank you, everyone.
Thank you.
Bye-bye.